Okay, so this is like a video where we will continue and we will try to solve, and I'm gonna show you how to transform or rearrange these functions so that you can easily draw the chart of these functions. Though it's kind of sophisticated thing, but as I said, this is more advanced level and it's really dedicated to students who really want to understand more deeply how to do that. So let's start with the first function, which is given by this relation, and basically this one is really not like very hard because the procedure remains the same, and it's gonna be really easy. The first thing you have to do is rearrange the denominator so that you will rewrite it like 2 times x plus 2. So it's very important to have like only x and multiple of 1 being here. Why is it good for? Because now the same procedure applies like we did before. We want to find the same expression in the numerator, so it means we will rewrite it like x plus 2 over 2 times x plus 2, which is good news, but there is one problem with this, because these two numerators are not equal, and if they are not equal, then this equation wouldn't be correct. So we have to add any number, some number here. Like I do it the same way I did before. We have to do the addition in the numerator, so that x plus 2 plus any number, but remember this can be a negative number as well, and then it will be like not addition but subtraction, and it must be equal to x take away 1. This is kind of good news because we will get rid of x's again, and it will lead us to the equation 2 plus e equals negative 1. So e must be, and I think it's really clear, negative 3. Okay, this is something I just said a couple of seconds before. So though we did plus e, and as e is negative number, this will lead us to something like that. Let me delete this one, and as we calculated, e must be negative 3, so we can put here, instead of plus e, which was just for the explanation how to get that, take away 3. Then it would mean that we can again rearrange with the same procedure like before, this fraction to x plus 2 over 2 times x plus 2 take away 3 divided by 2 times x plus 2, and we can simplify this one, so our function will be 1 over 2 minus 3 over 2 times x plus 2. I will keep this function in this form because, as far as we already know, it's important to have like 1 times x, because then this number really means the transformation or moving the graph to the right or to the left. So again, we start to draw our function, and our parent function is 1 over x, okay, which gives us this chart. And please remember the same thing I said before. Here we have still our vertical and horizontal asymptotes, so our function will never pass through 0 or x or y coordinate. Okay, next thing we can apply is transformation plus 2, which means basically we will transform our graph and our vertical asymptote to negative 2. So if you think about it, the graph will be like this, and the red graph is then the function 1 over x plus 2. Next transformation we want to apply, or we need to apply, is multiplication of number negative 3 over 2. Negative, please keep in mind, we can split it in two parts, but I'm not gonna do this because multiplying by any negative number would mean that we shift all the values, or we do the reflection over the x-axis. So all the values which are above x-axis will become negative, and all the values which are below x-axis will become positive, because positive times negative means negative, and negative times negative means positive. So our new chart of our function, and let me just write now first the function negative 3 over 2 times x plus 2. We keep in mind that our vertical asymptote will remain on the same place, so it's here. This has nothing to do with moving our horizontal asymptote. The only thing which will change now is that the function will flip over the x-axis, and all the values will rise a little bit faster than they did before, which maybe is not very good, which cannot very good be seen here, but you should keep this in mind. Okay, and now the last transformation we do is the addition of I wanted to use the green color, is the addition of 1 over 2. And this transformation would mean what I already explained, that our horizontal asymptote will be moved to the point 1 over 2, which is 1/2. So, and let me draw it in the new chart, in the new xy plane. So this is our x and y axis. The first asymptote will remain on the same place. So negative, let me put it here, negative 2, and as it is gonna be moved to 1 over 2 or 1/2, this is my second asymptote. And all the parts of my hyperbola will remain on the same place. So this is basically my chart or graph of my function given by this definition, or as well as this definition, as they are equal. You can again check this with the Desmos. You can again calculate the intercept with x-axis and the intercept with y-axis. And I'm not gonna repeat what is going on here. The only thing I'm gonna check or do for you as well as for me, because I want to be sure that the graphs of the function are really done properly. So let me open your favorite Desmos and let me graph the functions and as well the asymptotes. So x take away 1 is my numerator, x take away 1 in the numerator, and 2x plus 4, 2x plus 4 in the denominator. So this is my first function. Now I'll draw the asymptotes, which is x equal negative 2, x equal negative 2, and the second asymptote y equals 1 over 2. Very good. And now let's see if function given by definition y equals 1 over 2 take away 3 over 2 2 times x plus 2. Yes, okay, so everything is fine. First of all, let me make this print screen. of the chart, and let me share it with you. So this is the graph, this black line of the function x take away 1 divided by 2x plus 4. Okay, and you can see also the asymptotes, vertical and horizontal. And now I will just turn on the function we have found out, and please have a look that these black lines will be replaced by green line, and the graph will remain the same. Let me do the print screen. Okay, so let me delete this one. Voila. And as you can see, it is really the same function as we had before. Okay, so our job was done properly and we are really fine with that. Okie dokie. Now there comes, let's say, like the biggest challenge of today's video, and this is how do we do the transformation of the last function. But basically, if you would think about all the things you have heard till now, you just put together all the information which I gave you till now. So what is the most important thing here is that we take 3 out of the brackets. So in the brackets there will remain something like 3 times bracket x take away 1 over 3, because 3x, this is gonna be 3x, and this multiplication is gonna be -1. The same procedure you apply in the denominator, so it's gonna be 4 times bracket x plus 3 over 4. And now the tricky thing is the same procedure as we did before. We want to have this expression in the numerator, so we force the numerator so that this expression is there, which would mean that we have 3 times x plus 3 over, sorry for the number 3 over 4, and in the denominator x plus 3 over 4. We are now happy because we can see already that this will be cancelled by each other, but the problem is that this numerator is not equal to the numerator on the left side of, let's say, our equation. So we have to again, let me write it the same way I did before, to find some number so that this expression will become this expression, or more precisely this one. So we have to solve the equation so that the numerator is equal to, let me really write it like this. So if we simplify the left side of the equation, we will get 9 over 4 plus e must be equal 3x take away 1. Again, the same procedure, we get rid of the terms. So 9 over 4 plus e must be equal -1. We take 9 over 4 from both sides, so e must be equal -1, take away 9 over 4, which is -4 over 4. And as you can see, we do the same thing like we do here, but sometimes you do it like faster, because you know number 1 can be represented by fraction 4 over 4, so it will be number -13 over 4. So the number we are looking for here is -13 over 4. Okay, so let me put it there, and let's do another simplifications here. And please remember, really the number is -13 over 4. Let's do the check. 3 times x plus 3 over 4 take away 13 over 4. Is it the same? Is it equal to 3x take away 1? let's check this out. So if we do the multiplication here, we will have 3x plus 9 over 4, take away 13 over 4, which is 3x, take away 1. This is really what we wanted to get. So we are correct, we are right. And here comes another tricky thing, but the procedure remains the same as before. We can write these like two fractions, 3 times x plus 3 over 4 divided by 4 times x plus 3 over 4, take away 13 over 4 divided by 4 times x plus 3 over 4. As you can see, this will be cancelled or simplified, so this is gonna be like 3 over 4, take away 13 over 4 divided by 4 times x plus 3 over 4. We could basically remain with this super special number, but I'm not happy with that, and it would be really hard to sketch the graph like really properly. But from this you can see and find out what the asymptotes will be, okay? But it doesn't matter now. I want to show you the whole thing. So basically we can simplify this fraction, like this is gonna be 3 over 4, take away 13 over 4 over 4 times x plus 3 over 4 over 1, okay? As this is like huge fraction, but you already know that this can be simplified this way, inner parts by inner parts and outer by outer. So it's gonna be 3 over 4 take away 13 over 16 times x plus 3 over 4, and this is our function we were looking for, and now we are able to draw the chart of the function really properly. So let's do it. Again, the same procedure applies. We start with the parent function 1 over x, which is this one. The second thing we do is the transformation, or we move the function, and we move the asymptote to negative 3 over 4, and this is our chart or graph of the function 1 over x plus 3 over 4. What do we do? Again, we have to keep in mind this is negative number, so these hyperbolas will be reflected over the x-axis and multiplied by 13 over 16, which will change our y values. The function will rise slower than it is rising in the red example, but it doesn't have any impact on the asymptote. So this is negative 3 over 4, sorry, and our chart or graph of the function will be like this, okay? And the last transformation is, okay, let me write it here, this is negative 13 over 16 times x plus 3 over 4, and our last transformation is we do the addition of 3 over 4, so we shift the whole graph up, or each point up, but the main thing we do is that we shift the asymptote of the graph. So what is critical or essential for drawing the chart are these two asymptotes. The first one is negative 3 over 4, this is vertical, and then we have the horizontal, which is positive 3 over 4, and our hyperbolas will remain the same. So this is our final chart of the function. Let me do the check again with the Desmos, so that I'm pretty sure, and I'm sure I did it properly. So, and I will also draw the asymptote. So my original function is 3x minus 1, 3x minus 1 over 4x plus 3, 4x plus 3. My asymptotes are x equal negative 3 over 4, and my horizontal asymptote is y equals 3 over 4, and the function after all these super special tricky things is 3 over 4 take away 13 over 16 times x plus 3 over 4. Okie dokie, I'm done here. Everything fits, everything is nice. So let me share with you the first print screen, which is the function given at the very beginning. And as you can see, our chart of this function, okay, is really drawn like this. Okay, this is my function, and the blue line, or purple if you want to, my asymptotes are in red and black. And now let me just prove, and I will turn on the second one, and let me make the print screen again. So I just turned off the function which was given at the very beginning, and I'm now just showing you the graph of this function. And as you can see, both curves or hyperbolas are the same, so we are correct. During the next video, I will try to explain another approach how you can find the asymptotes, which I also explained during the lesson, without calculating such a tricky, super special, clever math ideas how to do that, without knowing or without implying any information about the limit of the function. Okay guys, thank you very much for watching the video. Enjoy, try to figure out all the stuff by your own, and have a nice day, good night, and see you during our next videos about next topics. Bye.